Most people check foundations after they're poured. Architects don't. Here's what actually matters before the concrete goes in. Welcome to the office. Let's talk. And specifically, let's talk about this first video series that I'm calling Field Notes. Quick job site tips of what happens when you go to the job site and what to look for when you're out doing specific walkthroughs and during specific phases of construction. So today, I just want to walk you through one very specific aspect of a job site walkthrough, and that's going to be foundations. We're going to start there because that's where all buildings start. So when you first get to a job site, you want to look at the foundation, and it's probably going to be in the formwork stage. But you want to look, does the overall shape match what it should? Does it look right? As you can see here, this foundation is a slab-on-grade, which is very common in this area. We have pretty rocky soil, but that means the concrete's being poured directly on a prepared soil with reinforcement in the slab. Slab-on-grade is most common here, but you might, depending on where you are, you might have different types of slabs, foundations. You might have piers, which are holes with basically columns drilled into the ground with rebar coming up from there. You might have mat foundations. You might have cardboard forms, carton form foundations. I've seen a lot of that. But the most common, at least in the areas I've worked, is this slab-on-grade. So here you want to look closely at the formwork. And this is to check it for accuracy. Here I'm looking at the forms to confirm that they're at the correct finish floor height, that they're level, and that when they pour the concrete, it's going to be at the right level in relation to the ground next to it. Later in the video, we're going to see a finished pour, and as you can see, this is right where we expected it to be. But if you don't get it right now, it could cause a lot of problems down the road. So you want to make sure that the formwork's in the right shape and that it's all at the right height and it's level or able to be sloped to drain water away. Next, we're going to look at the rebar. So rebar is one of the most common issues you might see early in your career, is that it is often sometimes sitting directly on the ground. So rebar should never touch the soil because you want to have the rebar sitting somewhere in the middle or even the top of the slab. This has to do with the structural components of it. You know, you probably have learned in school, but concrete is good in compression, but it's only good in compression. You have to add the rebar in there, but if the rebar is at the bottom, it's not doing it in the right location. So you want to have the rebar standing up. You want to check for what's called dobies or chairs. These are little supports that hold the reinforcing steel at the correct height. So it ends up in the middle or the top of the slab, depending on the design. And in our cases, at least, this is going to be referenced in the structural drawings. So you want to check the structural engineer's drawings. If there's chairs missing, if they're spaced too far apart, or if they're inconsistent to where it like sags and the rebar is sitting on the ground, you want to note that in your field report and report back to your architect or to the contractor or the owner, just letting them know that you found some areas where the rebar was sitting on the ground. You also want to make sure the rebar is tied consistently and properly, that it's not just kind of sitting there loose, so when they pour the slab, it doesn't move. Another important aspect when you're looking at foundations is checking all the penetrations and making sure they're accounted for properly. This is one of the hardest things to get right. We add sleeves or we add plumbing into the slab before the concrete's poured, but if it's not in the right spot, it's very difficult to make that change later in the field. So we usually will coordinate with the contractor to try to locate exactly where the plumbing fixtures need to be, floor drains, toilets, utility sinks. We try to locate those, but we're trying to locate those on a slab that doesn't exist yet with no walls to measure off of. So we try to give them dimensions that show them exactly where it needs to go. And even then, you know, sometimes measurements can be off a little bit. But here you can see the plumbing here is stubbed out directly where it needs to be. And if any of this is missing or it's in the wrong spot, cutting the concrete later, that's going to be very difficult. So we try to avoid that as much as possible. Also, depending on your region, your contractor should be placing a vapor barrier between the ground and the slab. This helps control moisture migration, and protects flooring materials from vapor coming up through the concrete. And that's something that we also coordinate, and we make sure that it has on the structural engineer's drawings. But you always want to check if it's supposed to be there, that it is there, and that it's intact, and there's no tears, there's no rips. It's very difficult to keep this nice and clean and not torn up, so you want to just double check that. Next, you kind of want to walk the perimeter around the formwork to see how the slab meets the surrounding grade. Here you can see certain points where the slope directs water away from the building. And these early grades are just as important as the slab itself because they help prevent long-term drainage issues. You don't want a grade adjacent to your slab that's higher that's going to bring water into your building. So your goal on this foundation visit isn't to direct the work. It's not your job to tell the contractor means and methods, but your job is to observe, document it, and communicate it if something seems off. You're checking for consistency, the formwork, the reinforcing, the location of utilities, the relationship between the slab and the site, and you're building a habit of seeing patterns, understanding how things come together, and recognizing potential safety issues. But when you're there, just make sure you're documenting everything. Take plenty of photos, far more than you think you need, of the corners, transitions, utility locations, vapor barrier, rebar. These will help you when you're writing your field report and referencing the stage later in the project, because you can't unpour the slab or unplace the concrete, but you can refer the photos that you've taken. So the foundation stage, it's honest, there's nothing hidden yet, but it's also one of the best times for you to sharpen your eye as a designer. So if you're just starting your career, every site visit, it's going to teach you something new like this. So take these opportunities to try to learn as much as you can. When you get back to the office, maybe ask your supervisor if there's something you were unsure of, because these are things you don't normally get to see in a building. As a normal person, as an end user, you're just walking on the floor. This is the time you get to see how it's actually put together. So take a minute to really appreciate and understand what's going on here. Okay, that's it for today's first field note. Make sure you stay curious. I'll see you in the next one, and let's get back to work.